Hey everyone, this is Sean Kiewit, and this is my final project, TensorFlow and Neural Networks, Applications in Retail. So the goal of this project is to develop a classification system to solve difficult classification problems typical of retail environments. It's meant to be generic to solve really any of the classification problems such as recommendations, customer loyalty. I've chosen a particular one called retail chargebacks, and you can think of chargebacks as fraud for right now. So the agenda is go through a little bit of background of what these chargebacks are, go through our problem statement, um, look at our selected technology, which is TensorFlow, corpus development, data partitioning, and then our neural network setup, and then summary. So to get started, a bit of background on chargebacks. So retailers deal with this every day, and when you pay with a credit card, what happens is, you take a transaction, you pay for a good or a service, and the merchant, the money moves from your issuing bank to the merchant's bank, and no problem. But when there is an issue, like the merchandise is bad or faulty, and you bring it back, and the merchant won't, refund your money or whatever, you can call your issuer and say, hey, this is the situation, and the issuer will get involved and charge back or basically debit from the merchant the money in order to get them to cooperate. Mostly we see this today in fraud. So your card gets stolen and you get your statement and you see, hey, I've got these charges and they're not mine. And so you call your bank and get them removed. Well, it's great for you to get them removed, but meanwhile, the merchant is out, in many cases, merchandise. So let's say in the case of a big screen TV, somebody bought it with a stolen credit card. The TV left the building, and so now the merchant is out of TV. And then when the cardholder charges it back, they're out the money too. So it's costly concern for retailers. It's growing, and there's just not a lot of great technology available to the SMB market right now. And so the problem we're trying to solve is how do we classify these fraud events or chargeback events using the retailer's own data to do it. And so in comes our hero TensorFlow, our class favorite, to save the day. So we're going to take the TensorFlow framework and libraries, and we're going to use three different ones, the wide, the deep, and the wide and deep neural networks to try to help classify these chargebacks in real time. So this is the framework we're going to use in those in particular. If you remember from class, the architectures of those, the classic linear regression, linear and deep, and then the deep architectures. But that's only part of the solution. The application I'm going to demo, there's really three parts to it that are all equally important. One is the first part, which is called corpus development. And for this project, we're going to use a payment corpus. And let me tell you, this is probably the most important part that I found in neural network development, is getting this part right. So getting your data right. This data partitioning part two is getting your testing and training sets right. And of course, three, getting your hyperparameters and learning rates and stuff like that set for your neural network. Those three parts. So part one in corpus development, and this is a great quote from one of the books I read on this, is so true, that he's citing research that says that you get better results if you have better corpus than you do by making better algorithms. So for the last 3 weeks, I'd have to say that's the most true statement I can communicate to the class. It just takes a significant amount of work on the front end to get your corpus into the right form that you can feed into a neural network and get great results. So it's important, get a large data set. You need to clean out the nulls and the bad data as best as possible. You got to consider removing outliers. So if you have outliers that are really skewing data, you have to figure out a way to normalize that data down or remove it. Obviously normalizing data, and then feature engineering. This is a big one. There's just some features that don't help the network. In fact, they hurt it. So, feature engineering is basically finding features that are important to feed to the networks and the ones that are not important to feed to the network. So, I spent a lot of time on that in the demo. Here's a screenshot of kind of that in action. We're using the Python Panda data sets to visualize data and take a look at what it looks like and what we're sending to the network. This is just a detailed side-by-side view of that. One of the histograms. So corpus development, big deal. Got to get it right. Then you move on to data partitioning. I'll go through this in some more detail in the demo, but just for now, just know this is a huge part to get right. If you get it wrong, your network doesn't train correctly. And then, of course, the neural network setup and training. So in this particular demo or an application, you can set up 3 different network types: the wide, the deep, and the wide and deep. The number of hidden layers in each network, and then the number of training steps. And then this is an interesting one: continuous columns versus categorical. So this is, I'll talk about this more in detail in the demo, but getting these right is critical on these networks specifically. So, so before I jump into, and this is just an example of getting these right in TensorFlow, the categorical and the continuous columns that we're using. So before we get into the results, I'm going to go ahead and dive into the app and just show you how it works. So this IPython shell or notebook, so you'll get that in the zip file, and you can just speed through. The 2 really important parts to start, which I cover in the report document. You need to be on TensorFlow 1.1. So if you're not on it, you need to get on it. And the way to do that is you can just type, I think it's pip install or update TensorFlow, and it should get you the last one. This has only been out for a couple weeks, but we need it for this demo to work. And then these modules, same thing. There's instructions in the text on how to import these if you haven't, but I usually just use Conda installer or pip. We've used most of these before, so it should be not a big deal. But the instructions are in the report if you need them. So again, the application has 3 parts: corpus development, data partitioning, and TensorFlow. So no big deal there. So we'll start with corpus development, and here we'll download from S3 instance a file which is really representative, and it's been sanitized and cleansed and all that kind of stuff for privacy. But this is really a file you could get from or a retailer would really get from their bank, and it's pretty typical. It just has their payments, credit card payments in there, and what the interesting thing we added here was a bit at the end that just says, hey, was it charged back or not? So just true or false at the end. This takes a bit of time to download. It's a little over 2 million records. It's about a little less than 300 meg. So I won't download it here. I'm on a slow connection, but I downloaded it earlier, and if you did, you can uncomment this line, and it'll just pull it from the file system. I'll leave that, let that run, but this is what the data looks like. So you've got pretty normal data. You've got some date time parameters, last for the card, expiration, year and month, and then I'm not sure what these indicators are. I can kind of guess, but I don't know what the values are. The total amount, tip, and then this chargeback field is where we would see a 1 if it was a chargeback. So far so good. The data loaded. I just hit that right. Hit it again. That's my mistake. But these are the histograms I showed you. Now this is important. The first thing I do when I look at these histograms, I try to figure out what are the continuous and what are the discrete or categorical columns. So generally, anytime you see data basically grouping around an integer or a number with no points in between, those are categorical labels. And so you want to write those down because these will be the categorical labels we put into the categorical group. And then these continuous ones, which are, look more like a normal curve, those are the ones that we put in the continuous category. So that's kind of the first thing I look for. Let's see if that's done up here. Yeah. So let's rerun this one. So that's a big deal to show that. And then what the next thing I look for on those graphs is these, in the continuous columns, these groupings that are far to the axis. And that generally means there's an outlier somewhere in the data. And so just to prove that to you, I'm just looking at total amount there, right? So if I were to go down here and take a peek at this graph in a side by side, you'll see like this big outlier way over here that is messing up our data. So in pandas, it's really easy to remove that. You can, this command right here will remove it. You say just delete any amount that is, or make a new data frame with any amount that's less than 2000. And then I'm going to drop these two columns just because from trial and error I know they're not helpful. So I'm going to go ahead and run this again. Oops. Helpful if I have my mouse on it. There you go. And then run this plot again and see what we get. So you'll see here now we're down at 20,000, and you'll see we have a much better graph here. By the way, this graph is pretty fun to play with. You can turn it around and do side-by-side up and downs. You can play with your sharing x-axis and y-axis and your bin count. So this is really powerful. And one note too is this drop NA or drop nulls. I've been burned by this a good bit last few weeks. Is this just drops nulls out of your graph, not out of your data. So it's probably helpful when you're doing your first steps to leave the drop NA off just to see if you have any nulls in your data that you may want to remove. So anyway, moving right along. Hurry up. So that's kind of the initial take of the data. And then I've got this command here, and this will take and do an overlay of all of the data, of all the features on the same graph. So the blue here is normal and the green is chargeback. So this is really helpful to identify features that there is a significant skew in the data. It does this weird thing where it pushes it like that. Anyway, it shows a weird skew in the data. So this one, the trick is to watch the line, the blue line versus the green line. So this, you can see there's a green line shift here that's significantly shifted to the right. So this one more than likely will be a good, what is that, month? I'm sorry, day of year. So that one would probably be a really good indicator. Some of these others that are not, you see like these aren't really, they're kind of hard to tell, like the lines don't really change that much. These are, it would be hard for the neural network to pull out those values. So anyway, you go through this kind of rinse and repeat cycle of every single graph and go through this cycle of reviewing, is there something here? And you'll probably have to do a larger, like the graph above where we did the individual amount. So anyway, it's important to get this right. It says corpus development, I can't stress enough, is a really, really big deal to get right. So that's the last graph there. Okay, good. So that's the corpus development. Spend a lot of time there. If you get that right, this last part gets really easy. So before we go into the next part of this, I'm going to go ahead and stop the video, and then you'll get part 2 in video number 2.